Good day, Dr. Driving. We are from Group 9 and our group member consists of me, myself, Yin Qian, Ong Pei Yee, Professor and Chuen. And our assignment title is Surface Architecture. So here is the overview of our assignment. First one is the introduction, and second is the history and literature review. The third is current state of surface architecture. Fourth is future prospect, and the last one is conclusion. As for the introduction, we can see that nowadays serverless architecture is transforming the landscape of application development and deployment. Serverless architecture has emerged as a revolutionary paradigm, fundamentally altering how developers approach building and scaling applications in the cloud. Unlike traditional server-based model, serverless computing abstract away the complexity of infrastructure management, empowering developers to focus exclusively on writing code to deliver value to their users. In this presentation, we will embark on an exploration of the pivotal aspect of serverless architecture, including its history, advantages, challenges, and future prospects.
Good day everyone, I'm Ong Pei Yee. Now, to understand the significance of serverless architecture, we will go through the evolution of computing paradigms. We will see how each era, from mainframes to personal computers and cloud computing, has paved the way for the serverless revolution. In the IBM era, mainframes facilitated synchronous computing through shared access, while the introduction of virtual machines revolutionized the landscape. The PC era saw standardized hardware integration, fostering innovation and new business models. The advent of cloud computing provided seamless access to shared resources, accelerating digital transformation. The serverless era, marked by AWS Lambda's introduction in 2014, enables code execution without server management, driving automatic scaling and building based on real compute time. This progression underscores how serverless architecture empowers developers to innovate efficiently without infrastructure constraints, marking a significant leap forward in computing paradigm. Next, in the literature review, we'll first look at the understanding of serverless architecture. Serverless architecture intercepts user requests and events, dynamically allocating compute resources without the need for manual infrastructure management. This event-driven methodology ensures automatic scalability and cost-effectiveness, with serverless functions typically being stateless and ephemeral. To understand the profound influence of serverless architecture, let's compare it with traditional architecture. In traditional setups, manual management of infrastructure is required, whereas serverless architecture automates infrastructure management, scalability, and billing. Moreover, serverless functions are stateless and depend on external services for data management, streamline deployment across different applications. Next, I will pass it to Huaysze to continue with the discussion.
Hello sir, I'm Huaysze and now I'm going to talk about the current trend of serverless architecture. Why serverless computing? Serverless computing is perfect for small to mid-sized apps with unpredictable workloads. It scales automatically, reducing cost and operational burden. It fosters rapid experimentation and quick iteration, and enabling a fail-fast approach. With easy deployment, event-driven execution, and pay-as-you-go pricing. Serverless accelerates time to market. However, a skilled team is essential to leverage these benefits efficiently. Overall, adopting serverless leads to agility, cost efficiency, and scalability. I have done some research on this. According to the 2022 State of Serverless report from Datatalk, there are 70% of AWS customers, 60% of Google Cloud customers, and 49% of Azure customers are currently utilizing serverless solutions. According to the research, some benefits or pros include serverless architecture such as reduced operating expenses, scalability, cost efficiency, rapid development, granularity, and event-driven flexibility. While serverless offers numerous benefits, it comes with challenge, which is cons. The challenges include vendor lock-in, limited function execution time, debugging complexity, and potentially higher costs. Next, I will pass the slide to my mates to continue. Thank you.
My name is Chuen, and now I will explain about the future prospect. Future prospects are divided into two, which is the future of serverless architecture and also the importance of serverless architecture in the future. Okay, now move to the future of serverless architecture. First of all is the increased adoption. The growth of adoption showed a significantly increase across various industries since more businesses realize the benefit of serverless computing. The second is the market trend. The telecommunication and IT sector are experiencing significant growth in serverless adoption driven by the increasing demand for digital content. The third one is the enhanced security and compliance. Serverless platforms often provide built-in security features such as automatic scaling, isolation between functions, and fine-grained access control. Fourth is the optimization for specific workload. The serverless architecture will likely become more optimized for specific use case and workload, such as data processing, IoT application, real-time analytics, and machine learning inference. Customize the serverless solution tailored to this use case can further improve the performance, efficiency, and cost effectiveness. Let's continue with the Cloud Connect event driver. The organization are increasingly adopting hybrid and multi-cloud strategy to leverage the strength of different cloud providers and on-premise infrastructure. Serverless architecture can seamlessly integrate with this strategy, enabling efficient workload distribution and resource utilization across the environment. The last one is serverless ecosystem and community growth. The serverless ecosystem has undergone significant evolution, marked by the proliferation of diverse tools, libraries, and frameworks tailored to support the development and deployment of the serverless application. Okay, now move to the importance of serverless architecture in the future. The first one is the elasticity and resilience. Serverless platform automatically scale application response to demand, ensuring the seamless performance under varying workload. The second one is the agility and time to market. The serverless architecture streamlines the development and deployment process, enabling organizations to bring new products and features to market faster. The third one is the resource optimization. Serverless architecture optimizes the resource utilization by automatically scaling resource up or down based on demand. And the last one is competitive advantage. The organization that effectively reverse resource optimization through serverless architecture gain a competitive advantage by delivering more cost-effective, scalable, and responsive application. That's all from me. Thank you.
In conclusion, for historical evaluation, serverless architecture began as a fresh approach to cloud computing. Over time, it has evolved significantly with notable advancement and widespread adoption. And next, for the current trend of serverless architecture, we observe a broad adoption of serverless architecture across various industries. Most organizations are capitalizing on its scalability, efficiency, and agility for their operation. And in the end, serverless computing is anticipated to sustain its momentum in driving innovation and enhancing competitiveness. Its influence on the development, deployment, and scaling of applications is expected to grow even more in the future. So that's it from our group. Thank you.